What else do we need to worry about? Well, obviously when a shape is rotated, a shape has descended, or a shape has been shifted either left or right, somebody needs to be notified. Like the entire environment needs to be notified so that uh, different things can happen based on those events. So let's add some events that we publish out to the environment, and we'll add them up top. And I think we obviously need one. Oh, shifter we already had. Descended. Yeah. Because I believe we're doing a descend, right? You can descend, can shift left or shift right, can rotate, which we have. Descend. And then let's add one for wedge. So that's when the shape is actually wedged, it'll trigger an event so that somebody knows to do something. Now, there are some behaviors that are going to be intrinsic to all shapes and essentially function the same way, right? So if we have this idea of being able to clear shapes and draw shapes generically, then at the shape level, we should be able to initiate that, right? Just generically call draw shape as an example. And then when we do that, it will actually internally call the underlying draw shape, right? The benefit here is that when we call it first, we can basically attach some behaviors and capabilities before making the generic call to the actual concrete shape object. So then we also need to be able to draw the shape. And clear the shape. So when we draw the shape, we essentially replace the background with the background of the field, right? So we need a temporary background to store it in. So just call it temp background. And basically, when we clear the background, then I'm not having a good typing day today. Okay. So all I've done is that when I clear the shape, I maintain the color of the shape. So I basically store that color temporarily somewhere and then set it to the field background, which we talked about before. This is relevant because I'll need that color later on when I'm redrawing the shape somewhere else, right? So I don't want to lose the color, but I first basically wipe the whole shape out. And then I can call the clear, right? Which what clear should do within the actual shape itself is now decide which blocks to set this shape background to. And then over here, I just do the reverse, right? So I just set it back. And then I just call draw. Now, along those lines, we can also add the ability to shift the shape left or right. and we'll make these virtual because they can be, that behavior could obviously be changed in the individual shapes. Oh my God. And then shift it right. And then we also need to be able to rotate it and make it descend. I think I misplaced descend somewhere. Yes, I did. And make sure I didn't also misspell it here. Yes, I did. Right. All right, now what does that mean, shifting left? Let's start there. So shifting left requires you to check to see if you can shift left first of all, right? So that's going to be determined by the shape itself. So we make that call. Then we're going to clear the shape, right? So that's going to, as mentioned, remove the color, set everything to background. Then it's going to change the value of the left to the new value, basically the column value. It's going to subtract 1 from it, right? So checking to see if it can move left will first of all check to see that you're not past 0, right? Or you're not hitting another shape, right? And then we move it to the left one, and then we basically redraw the shape. We draw the shape again. Now when we draw the shape, left has been moved over by 1, and when you draw the shape, it should draw the same shape with the same previous color, now in a new spot. And then once we're done with that, we need to let everybody know that the shape has shifted in one form or another. And this is the same thing that would happen if you're going right as well. So the first thing we're going to check to see if it can descend. I'm sorry, if it can shift left. Right, so check the field. And remember that we wanted to have the ability for blocks to have access to the field, for everything to basically have access to the field. It's so that we can do these sorts of checks, reaching up into the field to see, well, what's located in that area, right? And then basically, if it can shift left, then we basically just clear the shape, right? And we saw already that clearing the shape basically just means setting the background color for the shape. Nothing has been drawn yet. We're just setting the background color of the shape to the same color as the field background, but we're maintaining the old background color, right? And then we then call clear, which would then go into the actual shape itself and remove all those pieces. Okay, then once we're done, we basically move left, by 1. And then now that we've shifted it left over by 1, we just draw the shape again, right? And then we just need to notify everybody that I've shifted. And this essential thing needs to happen also when you shift right. So now it's can shift right. And then you clear shape, you draw shape, and then you check to see if it's shifted. And this is a +1, right? Because we're moving to the right. Now rotating is a little bit different, but it's essentially, it's a little bit different, but it's the same thing, right? So we're gonna see if we can rotate. Then we clear the shape, but this time what we're changing is the shape axis. And we're gonna increase it by 90. and then we're just calling rotated to let everybody know that it's rotated. So similar but the same. This doesn't have a negative because essentially it's just going around in a circle, right? So once it gets to 360 or whatever is more, then it goes back to 0, and it only increases by 90. Then the final one is basically descending. And descending has two pieces of it. If it can descend, then we go through and do the same thing that we've done up to this point. If it can't descend, then basically it means that it's wedged, and then we basically need to call the wedged event on it, right? We basically need to invoke wedged. So let's go ahead and do this. Then we say can descend. And of course, we're going to clear shape. And then we're going to bring the top down. So now you're going to different rows. You're starting at row 0, which is all the way up top. So you're going one by one. Then we redraw the shape. And then we just call the descended event that we previously specified. But what if we can't descend anymore, right? So descend is failed. Now we know that it's wedged. It's done, right? So we just call wedge. Passing in the field, right? And wedge would have some attributes, right? Because again, when you wedge something, the shapes, the blocks inside of the shape now break apart, and they now become part of that line that it got wedged at, right? Once it can't move anymore, we stop treating it like a shape, and we start treating it as blocks that are part of a line that goes, the horizontal line that goes the entire width of the game, right? And then when those horizontal lines get filled, there are some events that fire and there's some things that need to happen. That's how we do the scoring. So we, when we call wedge, we basically, that's an opportunity for us to set up everything associated with a line, right? And then once that's wedged, then we basically need to call wedge, okay? And in this case, when you wedge something, I think we need to pass the shape in. I think that when you wedge something, we should just pass in a shape, just so we know what is actually wedged, because it may be a little bit difficult to identify what that is. And so in here, we basically just pass this. All right, so now we've got this all set up. Can I do this right now? Is that gonna work? Nope, doesn't work. I forgot. Watch the other video for why that doesn't work, but basically, the UWP does not support, all the cool new capabilities in .NET 8. So the namespace is .NET 7, .NET 8. It's stuck in, I think, it's stuck in a C# 7. Well, let's see if we can do it. What the heck? So I'm gonna have to unload this bad boy. Do they even have an unload? Yep, unload project. And there we can see it. And let's see if we can just add a Lang version. And now let's see if this will work. Yeah, look at that, it worked. Okay, so you can enable file scope namespaces. Just gotta unload it, add Lang version, and then reload it, right? So, and that might give us some other cool things, who knows? But let's get to what we're trying to do here. All right. So the first thing that we want to do is we want to specify the eye shape. what is going to be the axis for this shape. And every shape is not going to show up as 0. I mean, you can decide essentially what you want. For me, for this thing, I'm going to set shape axis to 0. So when the lines come out, they're not going to come out horizontal. They're going to come out vertical. Make it a little bit harder for you. Right? And that's basically it for setting properties. The rest of what we're going to do is essentially overriding these methods, these abstract methods that were created at the shape level, at the base class level. So I'm going to implement abstract class, and that's going to add all the methods that I need. And now what I want to do is I want to go down to the draw method, and let's implement that. So how are we going to implement draw and clear, actually? So remember our shapes. Remember what they are, right? They are a shape has a left, which is basically a leftmost block, and it has a top, which is the topmost block, where that's the beginning block that the shape is starting from. And then we can draw other blocks relative to that shape relative to that block in order to create the block itself. So if I open up my Visio right here, let's see if we can sort of like demonstrate what we're talking about here. And basic shapes. All right. So basically, here's how, I guess, an L shape might be. And you could essentially say that from a shape perspective, this is the actual main shape. So this is 0, right? So this is in the grid. This is the block that we're starting from. If I wanted to, within that grid, because again, remember we have a block collection, right? And so now we know that this shape might be in, the start of this shape might be block 10. So the 10th, well, let's go 5, the 5th column, and the 0th row, or the first row. Start with the first row, right? Or the second row, right? So this is the main block that this starts in. This represents what we call the quote unquote shape, right? When we say the shape has a left and the shape has a top, that represents this. So for us to draw this shape, right, we would know that the block 4, that the block 5, 1 is part of the shape, that the block 4, 1 is also part of the shape, that the block 5, 3 is part of the shape, and that the block 5, 4 is part of the shape. So the shape is made up of all these blocks. Here's the prime block. Here's the prime block. Everything is relative to that prime block. So once you get this, you can calculate what all the other blocks are. Once you calculate those other blocks, you can either clear those blocks, or you can say that you occupy those blocks, right? And we're going to use that quote unquote notion of clearing and occupying to basically determine whether or not you can move downwards. Because if the block that's beneath you has been occupied, then you're wedged. That's essentially it. If any of these blocks cannot move down, then the shape is essentially wedged. It's stopped. So this way, if there was, let's say, a shape down here that's not part of you, right? So this is a different shape. Let's fill that with yellow, I guess. A different shape, right? Even though this guy can move down. Because this guy can't, because this line can't move down, you're basically wedged, right? And vice versa, if I was going downwards, and let's say I had a cluster like this, and these particular shapes, which I'm going to put into a group now, were up here and they're coming down, right? So they're coming down. There's no problem, have no problem, have no problem, have no problem, have no problem. Notice that the other shapes are passing through because they're fine. And there may be nothing underneath there. So there may be nothing down in this region down here, right? There's basically nothing over here. And all these blocks on the right, they can continue to move. If there was nothing on the left, they would basically continue to move. But because this particular block up here, because this one is essentially blocked, can't move any further, they're all stuck. The shape itself is wedged, right? So that's the basic logic that we're going to follow here. So for us to enable that, there's a couple of things that we need to add, really two methods that we need to add to the blocks themselves. We need to add a method and capabilities that allow for the blocks themselves to be cleared, right? Not, again, clearing a shape means clearing all the blocks that are part of the shape. So following this standard, for me to clear the shape identified here, it means that I would have to clear all the blocks tied to the shape, right? So if I set this to gray, notice that I can't just, if I want to make this shape something, I have to go into each individual block, as you're seeing here. I mean, Visio is a great example of how you have to do it. That sets it, this clears it, this sets it, and yada, 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 right? So I can set the color, right, and occupy that space, or I can clear the color by removing the any color or anything from any of the individual blocks. So we basically want to be able to do the same thing here. So to do that, we actually first of all need to go to block, right, and we need to add something to indicate whether the block is occupied or not. And then we need a way to basically clear it, which would make it not occupied. Right, so is occupied will be false in this case. That means it's clear. And then by definition, we will now set the background of this shape. Okay. So let's use the grid, and we'll also set this as a layout root. Actually, let's just call it block background. I'll use layout root. Okay. We're going to be changing the color of this thing. It's, you know, changing the background of the entire control. I'm not into that. I like to have a little bit more control over that because I like to be able to control the borders and whatnot. You know, just pretty much just do whatever you want. So it's better to just set the, you know, set the color by the grid. Now that we've set that to clear, the next thing is obviously to clear it. And as we've talked about on numerous occasions, the way we clear it is by basically setting the color of the block to the color of the game field. So conversely, occupying a block is basically the opposite. So this case, I'm going to pass in the shape. And obviously is occupied will now be true. And the background would now be the background of the shape. And we probably want to specify that the shape is that the shape being used, that the shape being occupied is basically this particular shape that you've passed in. So we need some place to store that, right? Let's call it occupying shape. And that's basically it. That gives us a general sense of what's going on. And this should be pretty, pretty straightforward to understand here. Just going over again. Basically, when I clear it, I don't care. I'm just saying, just clearing that shape. And honestly, when I clear it, then the occupying shape should equal to null, because we don't want that to remain. When I clear it, I say it's not occupied. I basically set the layout, the background color of this particular block to the field background. So it's going to be like it's transparent. And then when I occupy it, I pass in the shape. I store that shape, and I set the background to the color of the shape, and I specify that it's occupied, which I can then use later on to determine whether or not the shape is wedged or not wedged or whatever. So let's now go back to the eye shape and let's see how that's impacted. So now when we go to clear, what do we have to do? Well, we're going to have to, based on the axis, right? Because this is going to depend on the axis. Then we're going to have to find the blocks that make up the shape and clear each one, right? And then for draw, it's once again based on the axis. Find the blocks that make up the shape and call occupy on each one. That's basically it. And we sort of saw this once again in the Visio. You're going to go through one by one, and you're going to basically find the blocks that make up that shape based on the kind of shape it is, and also based on the axis, because right now it's 4-1, 5-1, like it's set up like that. But what if it was like this? What if it was set up like that? If it was set up like this, it would actually be a different set of rows and columns that make up that shape, right? Because again, our grid is static. We're not doing any rotate or anything like that. It's only we're basically recreating our visual layer, and rotate is something that we're calculating by using our pixels, but our pixels are always in the same position. It's just what pixels we turn on or off to basically create the feel of rotation. So for the eye shape, what does that mean? So the eye shape is basically only 0 or 180, or it could be 90 or 270, and that's basically horizontal, right? So as long as the axis is set up like that, we can draw it. Right? So the first thing we're going to do is we are going to put a switch statement, and we're going to use the shape axis. And in here, we're going to do case 0 or case 180. Then we break that. And then we have the same thing for 90 or 270. And in here, we basically okay, we didn't expose the blocks, so let's go ahead and let's expose the blocks. Do we have the blocks? Yes, we do. Change it to internal. Okay, so now field.blocks and left top is the first one. We're gonna clear that. And every single shape has 4 blocks, so this is pretty straightforward to do. I'll copy this over. So when we're doing left top, we're going to basically do the one before, right? So like it's just like this one. Let's see if I can go back. Just like this one, we started here and then we drew everything around it. It's the same situation here. So for a line, we're gonna start with the middle, right? 0 or 180 is basically, so let's go -1, then +1 and +2. And then over here, we'll do the same thing, -1. Now over here, we'll just start with 1, +2, +3, +4. And that's it. And then the same thing basically needs to happen when you draw the shape. So when you draw the shape, you basically go here. And instead of clear, we just say occupy. And we're passing in this. This is good because we'll have basically a template that we can use for everything. And it's not gonna all be this easy. Obviously the L's and all that stuff is gonna be a little bit different. But for this one, it's pretty straightforward. It's just a straight line. Now, I'm not convinced that I have this right. Yeah, I definitely have this wrong. So it's actually 90 and 270 should be like this, are the horizontal lines. This is a horizontal line. +1, +2, and there should be nothing here. So this is how it should be. And this is the beauty of programming, is sometimes you get things right, sometimes you get it wrong. When you get it wrong, you correct yourself. All right, here's the correct flow of it. Basically, 0 and 180 are both straight, right? 90 and 270 are both horizontal. I mean, 0 and 180 are vertical, 90 and 270 are horizontal. So this needs to be copied over here and changed to clear. Actually, both of them. So I'm just going to take the whole thing. Sadly, they will be recoding. All right, so that's correct, but now this should all say clear. I almost feel like removing or adding the field as a reference to, or the shape as a reference to clear, just so I don't have to do this again, because they're essentially the same thing. All right, so this gives us our drawing shape. And honestly, bruh, even though the shape is not going to be used, I'm going to add the shape here. And I'll remove it later on. I'm just going to add the shape here, even though it's not used at all. It's fine anyways, but the benefit of adding the shape is that I don't have to, basically everything essentially remains the same, and it's easier to copy and paste things. I don't have to type everything out, which is better for you because it shortens the video. Okay, so we got this figured out. That was a little bit gnarly, right? Now, the next thing we have to worry about is, well, so we now know we can clear it, we can draw it, but can it descend? Actually, before that, let's test this out and let's see if this works. So we've got the draw, we've got the clear. I think what I'm going to do is we're going to basically comment these out for now, just so we can get a working sample tested. Shape is fine. S shape we don't need right now. T shape we don't need. It's always good to test your progress to make sure everything is working. Z shape we don't need. So now we're just on the I shape. Let's build this. All right, build successfully. So I know now that I can clear and I can draw. So the next thing I want to do is I want to go to the game field, and I basically want to add this shape. All right, so I'll take shape. And then it basically works the same way. For me to draw the shape, I'm going to do shape.draw. And pass in this. So the game field allows us to add shapes. And then, okay, so we'll do it over here. And basically, let's modify this guy a little bit to give us some room to play with. So I'm going to set up a grid row definitions. I'll do 2. Set it up like that. Actually, why not just make it 100? A little bit better. And put this in the top row. And then create a stack panel, the bottom row. This is all going away, by the way. Just for testing purposes. And then let's put a button in here. not show shape, maybe I call it add shape. All right. And then up here, I'm gonna all right. So let's see how this shakes out first of all. I'm gonna add a board. Are you guys seeing this? Because this is mental. You're seeing that, right? You double click to open this. Here's a block. And it adds that to your code base. It's totally bizarre. This has happened so many times. Microsoft fixed that. All right, so border brush, let's go back to red again. Border thickness, let's do 0.5. See if we can see anything. We cannot see anything. But we're not going to give up. In the game field, when we load components, we should have a minimum width for this. I'm contemplating whether to add it. Because if you add it here, then basically you're locked to that size. So I think for now, I'm going to just try to make the game. Wow, this is crazy. I'm just going to. Let me see if just opening it in a regular way does this. All right, so this has something to do with double clicking it. It's bizarre though. So I'm just trying to make them perfect squares. All right, we'll figure that out later on. That's good enough. So we've got our grid now. Now we're going to add a shape. And we should be able to see that shape. So let's give the grid a name. Okay, so there's our game field, and now we are going to do eye shape equals new eye shape. Equal to 1. Let's go with 5. And then we can do game field dot add shape and pass in our shape. Okay, and of course we need to add a background color here. This is not showing up, so let's see if we can add. There we go. And we probably need some kind of collection for everything. Although I suppose we can just hard code it. I mean, as a game, I would suggest that as an exercise to enhance the capability. I'm gonna hard code it, but as an exercise to enhance the capability, I would suggest basically going into basically creating some kind of shape background list that can be pulled from somewhere, so that you can add themes to it, right? But for the purposes of this exercise, I'm just going to move this here and just say, hey, all eye shapes, this is the color for all eye shapes, so we don't have to worry about that. Let's see what happens now. Hey, we did it. We did it. We drew a shape. We getting there. Now that we got that working, right? Let's see if we can. Oh, it worked this time. Let's see if we can add a left and a right movement, right, to it. So. Okay. Call it left. Okay, so we've got a shift left, shift right. And what we want to do here, change the orientation real quick to the horizontal. And give these bad boys a little margin. There we go. So what we want to do now is we want to demonstrate shifting left and shifting right. So we go back to our eye shape, and we have not implemented that. Actually, we also need to add just thinking about it, and we also need to add a button for rotating. And a button for dropping. I mean, you obviously would not be doing this in the game, but for descending. This would not obviously be done in the game, but we just want to test it out. Ultimately, it's going to be automated by some kind of timer, especially the descending part. But for now, we just want to show that we can instrument that. All right, so now we know that we have the code in our shape. I can get rid of that for a second. So we know we have the code in our shape to shift left. Shape has shift right, shift left, and everything. So in our UI, I can actually, once the shape is created, so let's go ahead and let's have a so current shape. right? So that's our current shape. Now over here, we're just gonna do current shape. That's shift left, shift right, yeah, shift left. Pass this in. Pass game field in. Same thing. And rotate. And that's everything we need from here. Now we need to actually go into the shape itself, and we need to implement some of these abstract methods, right? Because for it to shift left or shift right, you have to have an implementation of can shift left, can shift right. For it to rotate, you need an implementation of can rotate. Descend, the same thing, right? So, and then obviously wedge is the same thing. We're not going to do wedge right now. So let's start with the shift left and shift right. So how do we do that? Again, it's all about the axes, right? The ability to shift right or left is going to be different if you are in the 180 degree. So basically, if you're vertical, or if you're in the 90, 270 degree, if you're horizontal. Obviously, you have more space to shift left if you're vertical, right? Than if you're horizontal, and vice versa for going downwards, right? Or rotating. It all depends. So how is this going to work? Right, so we're going to use that isOccupied property to basically determine whether or not there's a shape in that block. Or if another way of saying it is that if that block is part of a shape, then it's occupied, right? And if that's a block that we're trying to move to, if it's already being occupied by another shape, then we can't move there. And that's all we're really checking. The coding pattern is pretty straightforward for can shift left. We use 0 and 180 degrees as a vertically straight line, 90 and 270 as a horizontal straight line. In the case of 0 and 180, the vertical straight line, we basically need to check if the block to the left of any given block that's part of the shape is empty. And we go down each block of the shape, which again is a vertical straight line, and make that same check. So we start with the top one and we check if the left -1 is occupied. Then we go down to the next one, top +1, top +2, and then top +3. Should be noted here that at some point we're going to change this to basically make top the primary block, and then add one block above it, a top -1, if you will. But for the purposes of this overall exercise, it's okay to think about it this way. The bottom line is you basically start at the top, go downwards, and basically for each block in the shape, you check to see if the corresponding block to the left of that block is empty or occupied. Now, in the secondary scenario, the scenario where the shape is turned horizontally, we don't need to check every single block because they are all lined up on the same row. Now, note that because of the way we draw the shape when the shape is horizontal, checking to see if the leftmost shape is occupied means checking left -2. That's because from a horizontal perspective, we are using not the leftmost, but one before the leftmost as the reference point from which we make all our checks. And of course, in this scenario, if left -2 is not occupied, then we know that we can shift the entire shape to the left. So we're gonna add the shape, then we're gonna shift the shape left. Oh, look at that. And it won't go any further than that. Let's see what's happening. Why? It should go to the wire. So let's just check it out. Oh, I think I see what the issue is. So the issue might be my insistence on using a uint. Yeah, that's a bug that's going to rear its ugly head all over the place. So I'm going to go back to a normal int. Let's go to shape and let's change that. And this should be the same. It's a little bit of humble pie for being too clever for my own good. And the bottom line here is that I've got to go through the entire code base, and you do too if you've been following along, and basically switch every place where I had used an unsigned integer, uint, to just a regular integer. That means for every place where I had cast the uint back to an integer because an integer was needed, we can also remove that code because it's essentially unnecessary. Okay. We don't need you anymore. There we go. And that all works. So the issue there was that because uints don't give a negative value because they're positive, they roll over to the highest value. And the tests that I was doing over here in the I shape were based on this number being greater than 0, which it always will be. It'll always be greater than 0 because there are no zeros for unsigned integers. And so it was, when you were subtracting 1, it was going to the highest number, which is greater than 0. And then in my logic, we had created code to say that, hey, if you give me a value that's more than, let's go here. If you give me a value that's higher than my max columns, just give me the max columns minus 1, right? And same thing with max rows. So it was essentially flipping the shape over to the end of the game screen. And that was what's creating the issue, but this is working now. We've got the ability to shift left, down pack. Went through some issues there. Let's now see if we can shift right. So